Okay, so when last we left, we had done example number 1 on page 101. I don't think we need to do example 2. Do you guys remember what a Q is? Yeah?
Like the beginning.
Q is it's the reaction quotient. We'll just kind of do this by way of reviewing it. Reaction quotient. What else is it called? It is also called K trial. It is also called trial KEQ. It is no different than KEQ for the expression, except what is the one thing that is different? We use our initial concentrations. Now, for a question like this, where you are given moles, 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 tell me, is this correct? Don't write this down. I want to know, is this correct? No, why not? Oh, did I not put them in the correct spots? Oh, no, I didn't. You're right. Okay, so let's fix that. Is that correct? No, still not correct. Why? Because these are not moles, right? Concentration is moles per liter, not moles. So we don't want to do that. So we need to take all of those and divide by 5 liters. You should show this work. Okay, so concentration of SO2, 0.035 moles over 5 liters. Okay, and you would do the same thing for the other 2 as well. I could do that in my head. Why could I not do that in my head? I punched it into my calculator. I got 2.8 times 10 to the minus 3. That's obviously wrong. There we go. That looks better. All right. Now we can plug those numbers in. What do we do with that number once we have it? Yeah. Compare Q to KEQ. Best way to do that, to show your work very clearly, Q, which is 0.00112, is less than KEQ, which is 0.078. By the way, do I care about my sig figs for Q? No. Why don't I care about them? Because I'm being asked which direction. Does a direction have sig figs? No, so I don't care about the sig figs. So as long as it's, not a stupid number, just go with whatever you've got. And if that's the case, which way will the equilibrium shift? Therefore, the system will shift. Now, this is all you need to write. I'm going to put in red what you can use to think about it. Q, which is products over reactants, is too small. So what do we need to make more of? Need to make more product. Therefore, it's going to shift which direction? Right. Okay, you don't need to write this part, but this is how you can think about it. If you want to write that part, it's fine, but you don't have to. So, yes? Okay, so if you've got a Q situation and it says which direction will it shift, they will give you the Q. They have to. Okay? Now here's a little trickier one. We have 0.5 moles of each reactant, 0.3 moles of each product, and they're placed in a 1 liter flask. Will you need to show the calculation for those concentrations? No, because it is so simple. Just, it's going to be divided by 0.5, divide by 1, 0.3, divide by 1. You don't need to show that. But now we are asked, we aren't even asked in this question, it doesn't say which way does it shift. But if you think about it, we have 0.5, we have 0.5, we have 0.3, we have 0.3. Normally, we'd be like, okay, let's just do a rice table. Yes? But which direction is this equilibrium going to shift? Where am I going to put my plus signs in my rice table? I don't know either. Yes? And that's where Q comes in. We know we need to use a Q because both products and reactants are placed in the flask. So we don't know which way it shifts. In other words, we don't know where to put the pluses and the minuses in the C row of the rice table, i.e., we don't know where the plus and minus go in the C row of rice table. You don't need to write that all down, but basically what it comes down to is if you have both products and reactants placed in a flask, that's when you need to that's how you know you need to use Q. Okay? The rest of it's just by way of explanation. But how do I know to use Q? I've been given both products and reactants. So let us give ourselves a Q here. Q is SO2, NO2, both of those are initial, over SO3, NO, and we have our products are 0.30 each, and our reactants are 0.50 each. What do we do with our Q? Compare it to KEQ. It is bigger than KEQ, which is 1.5 times 10 to the minus 2, which is 0.015. Sometimes I like to rewrite it so it becomes really obvious to me which one is bigger. Therefore, the system will shift. Whoa, I missed all those words. System shifts which way? Left. And if you're like, why left? Then what I want you to do is I want you to say Q is too big. That means products over reactants is too big. So we need to shift away from the products.
Oh, wasn't the other one too big?
Always think about Q. KEQ is perfect. KEQ is perfection. Q is either too big, too small, or it is also perfection. Yes? And once we've done that, then this just becomes a rice table situation. So, you guys want to try that? The rice table part? Give it a go. if the system is shifting left, where do we put our plus signs? We put our plus signs on the reactance side. So plus and plus, because we're shifting left. And then we have minus and minus. Uh-oh. I don't have any equilibrium values. What should I use for my change? I should use X. Is there anywhere where I need to make that into a 2X? No, because none of them have coefficients. What comes after a Rice table?
Solving for K.
Solving for KEQ. My period 8 class is taken to calling it KEK. So Rice, then KEK. Do you need to write the expression? Yes. It's tedious, but do it anyway. What do we do now to solve this thing?
Algebra.
We do some algebra. What's our first step in the algebra going to be? We're going to take the square root of both sides because remember I promised you, what do you never need to use in Chem 12? A quadratic formula. And if you were to take those and multiply them out, you would get an x squared term, an x term, and a numerical term, which would give you a quadratic. So let's get rid of that. Here's a little tip. If you're writing work and you move somewhere else on the page, direct whoever's reading it to where you're going.
We just leave the whole number. I forgot.
So what you're going to do, this number, you're going to keep the whole number in your calculator. Now you guys get to churn through that algebra and see if you get the same thing I do. Sometimes you do better than I do. Awesome, thank you. That's okay. I understand. I understand. Did you get x equals 0.2127? Any questions on what I did there?
No.
No, we're good? Okay. And then we have to say, did we want x or did we want something else? So what were we asked for? Concentration of SO2 at equilibrium. SO2 is 0.30 minus x.
Wait, how do we know sig figs for this is not for action?
Pardon me?
How do we know sig figs for that?
That does not have the correct sig figs for x. Okay? I've just written down a bunch of digits. I've got the whole number in my calculator. Okay? I'm actually subtracting 0.212706.241. Okay? And it doesn't matter because I am limited here by that uncertain digit. So my answer is going to be 0.08729. And then I look at my answer and I say, this is in my 0.01 position. That means when I do a subtraction, it's also going to be in the 0.01 position.
Okay.
Which means our final answer will be what? 0.09 molar. Is good? Okay.
Is that 8-1?
Huh?
Is that 8-1 or
That's a 7. Whoa, that's a cool one. Okay, so your homework is page 103, all of it. There's only 3 questions.
And I feel
But I'm also going to assign a couple from Hebden. "52 is a bit of a challenge. You've not done anything like 52. Okay.
I might take a picture like I'm actually. Whatever. Yeah. No, I'll actually. Like, I didn't want to today. Oh, yeah, they're finished.
So that's really 6 questions.
I'm so behind on homework. So behind. Actually, ran stuff too fast. Maybe I should leave it. Six questions. Well, like.